All right. Well, thank you everybody for giving me the opportunity again to talk to you about Toppenish Creek. I am, this is maybe a little different than my thing went back. Sorry. There we go. A little different than a lot of virtual tours because it's about 50 miles of stream altogether, including Toppenish and Simcoe Creek. So I'm just going to give you as much of an overview as I can, as well as I can never stop, I can never help myself from talking about some of the really cool features of Toppenish Creek and why it's so different than a lot of other creeks in the East Cascade. So I'll have to work some of those elements in too. I'll be talking about the geography, some of those cooler elements I mentioned. I'll go a little bit into how Toppenish steelhead look in the context of the Yakima Basin, which points to why we should care about that population in the first place. Then the uniqueness of Lower Toppenish Creek, and finally a really quick tour of some of the macro reaches, basically working our way upstream to see what they're like. So to start with an overview, this slide in blue and red shows the precipitation gradient across the Toppenish Basin, which is outlined in black, and you see some of the major divisions of the basin sort of geologically. I apologize, the Basalt plateau up there should say Basalt plateau on your left. But the basic lesson is, like anywhere in the Yakima Basin, the further east you go, the more you're in the rain shadow and the drier it gets. And up on the Basalt plateau, where it's nice and blue, there are about 50 inches of rain. So the vast bulk of stream flow comes from up there. You get down in the southeast corner to the right, you're down to around 7 inches. It's really a sagebrush desert. And so there's a lot in between, a lot of variation. You get a lot of springs in the basalt slopes. Alluvial fans also have springs, but by and large, most of the precipit's going to be in the extreme west there. You can see the other interesting thing is you have Simcoe Canyon, so Simcoe Creek and Medicine Valley are kind of a separate subsystem of it, and we'll be talking a tiny bit about that. Same frame, just to show you what the satellite view is, showing green in the west. That's heavily forested. The basalt slopes are the dry forest and the transition into the shrub steppe. And then down in the alluvial fan, where there's a really abrupt transition from dry brown to bright green from irrigated agriculture. And it shows you most of our assessment area is in the alluvial plain, alluvial fan, and then Medicine Valley. And you can see that almost all of it has a super heavy irrigated agricultural influence, which is one of the reasons why we have some problems there. And why it's so deceptively bright green in those areas. Getting into the context of Toppenish Creek steelhead population in the Yakima Basin, I pulled some numbers out of the Yakima steelhead recovery plan. And these numbers, you should just use them to compare between the populations. They're not really absolutes. And I guess I draw a couple of lessons. So on the lower right, you have these two small bar graphs that say Sat, Top, Atanum, and Tianaway. That's what those abbreviations stand for. And it's basically a depiction of, on the very lowest graph, you can see how large the area of Sadis and Toppenish Creek watersheds are. They're about close to 600 square miles, whereas Atanum and the Tianaway are pretty small, down near the 100 square mile or 200 square mile range. However, if you look at precipitation per area or inches per square mile, you can see the situation reverses. So what I'm getting at is the natural setting of Sadis and Toppenish Creek in a basin like the Yakima Basin. You wouldn't expect them to be producing a ton of steelhead relatively. They're very dry basins, very large arid basins. But then when you look up at the table, you see across the top are the same steelhead populations. And then you see weighted stream area. This is a measure of intrinsic potential, which is a rough physiographic measurement using the area of the streams and the slope and the confinement and basic things you can derive from a GIS to get an idea of what their productivity for fish might be. Again, you see Naches and Upper Yakima should dominate. Historic abundance by ecosystem diagnostic and treatment model. This says that Sadis and Toppenish should be about a third of the basin's total run. Finally, you get to the very bottom, the 10-year average of actual observed adult runs. And you can see that Sadis and Toppenish Creek come in at about half of the runs. All of the runs are reduced compared to the estimated historic abundance, but the Toppenish and Sadis are holding their own. And I think for that reason, it's really important to keep those guys going, especially Toppenish that we're focusing on, while we do a lot of work in the Natchez to get that boosted up in the upper Yakima. And then finally, there's a trend graph. Steelhead runs there, that line graph, and you can see the line in bright red is the Toppenish population in comparison to the others. And I want to point out that for whatever reason, it did not experience the peak in 2010, 2011, 2012 that the Satis and Natchez population did. It just stayed flat and then it declined as well. And so it looks like the latest trends in the Toppenish population really are not good. All reasons here for me to pay special attention to it and figure out what's going on with the smolts. Michael, I'm sorry, you said not to repeat the initial presentation, but this slide is straight from there. But it's just to remind you of our assessment area, which is the section in yellow. And as you go to the left, to the west, it gets into kind of being obscured by the little black dots of the fish reds, but basically it goes up to the forks of Simcoe and to the dam on Toppenish Creek, right where Toppenish Creek, the text label is. Okay, switching modes a little bit. I want to, don't have long enough to do a great in-depth job. I have basically like a 45-minute show I could do on this, but Toppenish Creek, the geomorphic style of the stream is extremely unique. I would be interested if anyone could tell me of another stream like this in the Eastern Cascades. So if you look at the left two figures are from a great paper from 1992 by Nansen and Crow called the Genetic Classification of Floodplains. And what they tried to do is get to the physical basis of why different floodplains behave differently. And they did a lot of work with stream power, which is the amount of energy produced by a stream per channel, they're saying per square unit of channel. You can see on the bottom left, they call something a confined coarse textured floodplain. This is what a lot of our streams look like. If you look at Tainum Creek or Nainum Creek, Monastash Creek, even Tainum on a very small scale, they all have this confined, they're high power, and just to look at the relative power, it's 1,000. And then if you go to the the upper left, this is a stream with 10 watts per square meter. In other words, 2 orders of magnitude less than the coarse grain confined. And that's what Toppenish Creek is. So it's so much less energetic. It's so flat. There is no cobble. There is silt and mud and sand. And it's so sluggish that when it floods, it drops all those fine sand, silts, and mud and forms its own little natural berms. And then you get the stream running up higher than the natural back swamp. So in a natural setting, this system would be functioning sort of as a huge, vast, like slow-flowing lake during the flood season, and then the channel would retreat to that elevated channel, which seepage to the back swamps to maintain them. So a system that was perhaps perennially wet in the swamps, lots of off-channel habitat, and we can only speculate that it was probably pretty good for fish. And then finally, some of the uniqueness of this comes, and the reason why it's so flat and low energy is because if you look in the lower right, there's a depiction of the Yakima full belt, all those ridges, I just labeled one Toppenish, and the Toppenish Basin in yellow, that are being slowly, it's like a carpet that's being squeezed from two sides, and you get all these rumples. Geologically, that's what's happening with our giant layers of basalt. So these deep, round valleys accumulate a lot of sediment, and since it's sediment accumulating through the action of rivers, it's flat. That helps contribute to this really flat surface that Toppenish Creek flows through. I'm not going to dwell on this, except to say it's really exciting for me to imagine that a lot of the Toppenish Basin had 300 feet of water in it various times during Missoula flood time, and the floods brought in a heck of a lot of fine material for the creek to rework over the thousands of years since the last flood was there. Back to, I just can't emphasize enough how different the creek was and how different portions of it work today and how much it's changed. This is really about the change. So you have a quick rundown here, some work done by our consultant, Don Reichmuth, back 20 years ago now. Awesome hand-drawn figures. You have the old Yakima River running along the base of Toppenish Ridge right after the floods, which knocked it way far to the west. Then you have Toppenish Creek running in that channel in the next frame. So he considered this pre-1700, lots of pre-Lewis and Clark, pre-beaver trapping. And so you had this same anastomosing. You see the elevated natural levee from overbank flow. You see the back swamps, the same as in that floodplain classification by the other authors. And then you probably had, especially in localized spots, a lot of groundwater flow from the Yakima River. And I'm going to talk about about water temperature several times in this presentation because, you know, this passage inventory is definitely going to look at little diversion dams and unscreened pumps and and choked channels and things like that. But really, water quality is probably a barrier in some instances as well. And so I'm going to talk about water temperature as a major component of that as you start heating up in May, and some of the smolts are still running downstream. So probably there were areas along Toppenish Creek that got a lot of groundwater flow from the Yakima River. This panel in the lower left shows that. And then finally on the right, you can see all the modifications that have transpired. A big ditch was dug, Marion Drain. It interrupts the flow of groundwater. The creek slid out of its elevated position between its alluvial berms and slid down into the ancient back swamp. Could have happened because of an earthquake. Toppenish Ridge is still active, or could have been a lot of beaver trapping, removed a lot of dams, or localized modification by farmers, or likely a combination of all of that. But currently, we don't have that original back swamp alluvial berm system, even though the evidence is very rich on the landscape that that's how it once was. And finally, the creek has changed, and change is neutral, but in this case, it wasn't good for natural systems, for fish, very good for agricultural productivity, of course. And you had the typical suspects: land conversion, farming and grazing right on the creek banks, high levels of turbidity and all the chemicals associated with those little soil particles coming from agricultural runoff, dredging, which creates these incised channels that you see here in the lower left, and the introduction of industrial scale agriculture with the Marion Drain excavation here, its own steam shovel that sat in the drain as it dug it out. So this, I think this is kind of an artist exaggeration. I've seen photos and the thing itself is pretty monstrous, but this gives you an idea of sort of the scale of some of the drainage that was happening down there. All of this, of course, affected fish passage, among other things. All right, for the last portion of the show, I'm just gonna systematically work through the macro reaches that I referenced. I've just named them by sort of the most characteristic, the predominant characteristic of the reach, starting with the river floodplain, where the creek is flowing in the Yakima River floodplain in the old Yakima River channel. I have a short reach labeled the Refuge Reach because that's where Toppenish National Refuge is. It has a dominant influence. The middle floodplain, which is really where the classic anastomosing floodplain is. Incised reaches getting, sort of the connecting zone between the middle floodplain and the fans. Alluvial fans, where you still get a ton of gravel coming out of the mountains. All the gravel settles out there before the creek gets really flat. And Medicine Valley, which is its own special little place I'll talk about at the end. So I'm going to go upstream, and I'm going to just give a very nutshell description of each macro reach and then some of the problems we anticipate finding in our reach assessment or our barrier assessment. So you have, again, the creek snaking through. Those white arrows point to the channel itself in what is quite obviously, especially if you see LiDAR, the ancient Yakima River channel. It's a very wide area. The creek runs in the bottom of it. Creek doesn't come out of bank very much because it's really, in this much larger channel. You have farm pumps in the inset in the upper left. The white arrow points straight at a big pump array right in the creek. I've never eyeballed that one myself. We're going to be checking all of those to be sure they're screened properly. And then you see on the lower left a large, WIP diversion, Wapto Irrigation Project diversion called the Alfalfa diversion, where water from Marion Drain through a surface channel is routed down across Toppenish Creek and through those screens on the very lower portion down into the Sadis Canal to get irrigation water to the next section of the Wapto Irrigation Project. Currently, a fish coming from your left downstream can just hang a left if it wants and swim straight to Marion Drain. And so that's a really kind of unholy mixing of water and an ability for fish to get into bad places. So that's something that the corridor plan is going to fix, but we'll certainly be inventorying that too. And then there's altered water temperature, like I talked about. This is, we have a really valuable reference resource called General Land Office Surveys. And there is a really good consistent set of them done in 1874 over this entire assessment area. So when I want to get some inkling of what the landscape looked like, I go back and I look at these old maps and I read the notes. They note the vegetation in the water. And one of the really amazing things was Wanatee Slough is a big old slough. It's, big prominent landscape feature. And in 1874, it started in a springs about 2 miles from Toppenish Creek, 2 miles to the north, not too much south of Toppenish. And it was a large springs, and it created a perennial large spring brook that fed straight into the creek down on your lower right. Now just imagine, this thing is mapped, it's like 20 feet wide in the description, high quality, pure very cold groundwater popping right out at that springs and running down into Toppenish Creek. That's amazing. That's about 7 miles from the mouth of the Yakima River. So a fairly large source of spring water coming straight into the creek at River Mile 7 must have had really serious and beneficial implications for water temperature and water quality. Today, the situation is quite different. The agricultural slough has been extended north about 10 miles. The springs was obliterated. It's right where that white arrow is, the upper white arrow. And it was connected to the Yakima River about 10 miles up the valley to serve as the first irrigation canal within the reservation. And then as you come downstream, that slough, which probably still collects some groundwater, may at different times of the year be cooler than the stream, runs straight into Marion Drain. That's that linear feature in the bottom third of the big picture, running west to east, where the second right arrow is, the lower one. So basically, this large, probably positive influence on the water quality of the very lower portion of the creek has just been completely compromised and really basically obliterated. So that's a big deal in terms of fish passage, especially late in the year. I see I'm running out of time here, so I'm going to try to, unfortunately, move a little quickly. The Refuge Reach, I'm not going to say too much. Upper right inset shows the geometric, static, flat duck ponds. This was really bad up until about 10 years ago, and then the service has been working really hard since then to make the situation a lot better for steelhead. So I'd like to basically give some attaboys to those guys, Jason Romine and company that work with us. So thank you, and it's getting better, but it's still a real large landscape disturbance. The middle floodplains, the anastomosing part, you can see in the big picture, the big panel, all kinds of snaking channels, tortuously meander channels. Some of the problems that we think are here, there are at least 7 gun clubs, i.e. duck clubs with small diversions in this reach. The lower left inset, that white arrow points at a very rickety, horrible looking diversion dam and the attendant diversion ditch. Upper right shows Snake Creek, which is one of these places where I mentioned the distribution of flow has been changed. More water goes down there and sometimes fish go in there. Our pit antennas tell us that smolts do not have very high survival at all once they get into Snake Creek. Probably not because of any one diversion or passage barrier. The whole thing may be a passage barrier due to horrible water quality and habitat conditions. Incised reaches, just what it sounds like. The picture on the upper right there shows you a really not even particularly incised part of this reach. And in addition to the incision, which itself, isn't really a passage issue, there's a lot of infrastructure. And because the channel is degraded down so much, in some cases this causes drops and scour holes once you get past the foundation of bridges and some of the box culverts in these crossings. There's also large drains and large diversions in here. The Unit 2 diversion should be okay for fish, but there might be during floods some opportunity for fish to get into some of the old ditches. So we'll be looking at crossings here and at some of the what happens during high water. And finally, the most upper reach, aside from Medicine Valley, this is what I call the Alluvial Fan Reach, where there's a big old wedge of gravel that comes out of the mountains, and as the valley flattens out, it gets dropped. Its lower parts of the fan are similar to the incised reaches. You have many bridges and culverts. And you can see here is a picture of a culvert at Pom Pom Road on a side channel. Really no way to get through there as an adult fish if you happen to take that branch, that fork in the road. So hopefully they'll go back down to the where the side channel connects and swim up the main channel under the bridge, but you never know. And then at high flow, it can be an impediment too, just because so much water is coming through there. And also many bridges, box culverts, and you get to the upper portion of the fan. These stream reaches do naturally dewater during the summer, and it was really bad when there was sort of untrammeled usage of irrigation water. But we have now, we run a in-stream flow criteria where we turn off the irrigation to prolong the season of connectivity so that that's not really a passage impediment. Another aspect of the fan and the infrastructure, just a great picture I had to include from the aftermath of the '96 flood. And you can imagine the problem with head cuts, scour at bridges, unnatural channel configurations that was caused by when the '96 flood hit these crossroads that were built, like on a lot of alluvial fans, very unwisely. And so this is something that contributed to the problems I described. Finally, Medicine Valley. It's a cool little alluvial fan trapped behind a small ridge. So a bunch of, it's flattening out and then it cuts a nice little mini gorge through the narrows there on the lower right. basically it's not in bad shape. It's pretty rural, but there are some small crossings, private driveways and things like that, culverts, as well as some small diversions that we just want to check to be sure those are in decent shape. Well, I think I'm coming in just on time. I hope that wasn't too fast. And I want to thank you again for giving me the chance to talk to you. And I will be happy to take any questions I can answer.
Thanks a lot, Tom.
You bet.
I really appreciated kind of the overall view and you gave just of the geology, just as a geography nerd and somewhat less of a biology person. That was really interesting for me to hear about.
Oh yeah, it's I could, I could.
Any questions from the tag or the CC?
Is this, before we talked about Snake Creek, is this related to that?
Can't hear Tom.
I can't hear anybody.
Yeah, I think Tom, his mic is looking like he's unmuted, but we're not hearing you, Tom.
I'll wave at him.
I just texted him.
Thanks, Alex.
Goes, oh,
He may be.
I think he's rejoining.
Yeah, I think he'll rejoin. So in Tom's absence, I'll do my best to answer the Snake Creek question. I believe that this is a separate project that was motivated by Snake Creek.
Can you all hear me now?
no.
You can? Okay, great. I don't know what happened there. So I heard a question about Snake Creek, and I saw the chat question about budget. Yeah, Snake Creek is there. It's in the middle floodplain section, and it's one of the areas where I mentioned in passing that the flow distribution among channels has been modified. So there's some grade controls in there that were meant to enhance wetlands and have, but at the same time, they may be routing more water down Snake Creek, thus sending more smolts down there too. And what end up in May even being usually pretty bad habitat conditions due to little water, warm water, and lots of aquatic plant growth. So it is what you heard about before. We had some reservations about the previous project because we didn't have a proper context for it. One of the reasons for this assessment. And there were also, on our staff, there was some reluctance to kind of shut down an entire section of the creek without looking at other alternatives. So we may go back to that, but we wanted to understand more on a reach level scale what's going on before we kind of try to block off the entire Snake Creek section. Cost, I don't really have time, I guess, to get into a deep analysis. I basically did a rough, it's going to be two people walking around out there essentially and boating around in a two-person kayak and taking notes electronically. Some of the areas are quite simple. Some of those incised reaches, you're just going to be slipping down, probably going to do 5 miles a day. Some of the areas in the lower floodplain are really complex and are going to take maybe like a mile a day if you're lucky. So when I added it up, there seemed to be adequate time, 3 months over the summer, 3-4 months to do it all. But that's a great question. I don't really want to under budget, and so I'll go back and look at that. And then there are also questions about, how much is in the assessment budget for the surfboard. So, I would have to talk to Alex about that.
Jason, I comment Lawrence ditch is an issue.
Yeah, we know that already. This is an example of there may be more like it. Jason's referring to a ditch that was built. So much of this is driven by duck clubs, so much of it. And this was built straight to a duck club, and it's on tribal land, so we have full control now. And yeah, basically it diverts, it's a large ditch and diverts a large portion of the stream in a place not too far from where the fish are tagged. And we put a pit tag antenna on it, and Jason actually put it on there with his crew, and is monitoring it. And yeah, Jason, I don't know what the latest numbers are, but the email you sent me a month and a half ago wasn't too good. Looked like maybe 8% of the outgoing smolts were going down that ditch, and not very many of them were going back into the creek. Yeah, Jason says 8 to 10% loss. So right away, we know now. We wanted data. You know, we'll be coming back to some funding source, maybe the surfboard next year, maybe the integrated plan to look for money for a screen. We're either going to screen it or just close it down, one of the two. I'm not sure which. So that's an identified problem, and just indicative of the scale of things that can happen out there. It's very intricate. Some of it's heavily forested with willow trees. It's just, until you see things on the ground, it's very hard to know what's going on.
Jeanette had two questions, one about non-standard passage issues and one about contributions to mortality on different reaches and tributaries. Jeanette, would you want to kind of pose those two questions?
Sure. Hi, Tom. I'm Jeanette Smith. I'm Surfboard Tech Panel, one of your reviewers. I was just curious actually about, you'd mentioned in the proposal that you're kind of relying on, you know, standard DFW protocol for passage issues, but it sounds like you have kind of non-standard passage issues, and I'm wondering if you have other methods that you're going to rely on to give you that information in a standard way.
Yeah, that's a great question. Actually, the grant requires us to use DFW methods. Not that I object to that, but that's not just our choice. And I think that's a great question. You know, the things I think about are issues like Snake Creek, where the distribution of water may be off or maybe a problem. And then the things I mentioned about water temperature and aquatic growth. And so I definitely think we'll be taking water. We already have pretty decent water temperature data for a lot of that area. And as the team is out doing the assessment, I want them to collect water temperature as well. And so we should get a really good idea of the profile. I don't know if there's time to do, I mean, to branch off, we recognize water temperature is a big deal in Toppenish Creek. And part of what's going on, this project fits into a couple of different contexts. So it fits nicely into the programmatic context, where we have a Bonneville funded mitigation program happening that is sort of half of my job. The mission there is to restore and manage steelhead, to restore the run. And they work a lot starting sort of in incised reaches and upstream and on up into the headwaters. You have a wildlife program, also mitigation funded through Bonneville, that works in the lower floodplains, works in the wetlands, works on cultural plants, and the fisheries and wildlife program work really well together right now to coordinate so that the wetlands that the Yakima Nation manages are getting better for fish and don't harm outmigration. And then you have upcoming probably a multi-decade plan funded through the Yakima Basin Water Enhancement Project through the Bureau of Reclamation, called the Toppenish Creek Quarter Plan. And it is focused squarely on this same reach that we're doing the assessment on. And part of that is building a water temperature model, I hope, and really being able to take, it's meant to really change the landscape. It's meant to pull the irrigation water out of the stream and to restore the natural flow and water quality. That's the whole purpose of the quarter plan. And so there's sufficient money behind it and horsepower that we can do our best to do. You know, we should be able to make a good attempt at that. So I think that your question is good, and we will do our best to include those water quality and, you know, sort of aquatic plant habitat issues. And then the good thing is, if we identify them, this thing is complementary to those other larger efforts to be able to inform how we handle them or how we address them. Excuse me.
So my other question was related to, do you have any information on the contribution to mortality from different reaches or tribs throughout your assessment? And, you know, it sounds like where you set up pit tag arrays, you might have some ideas, you know, 8 to 10% loss out of the Lawrence ditch.
Yeah, again,
How-
we have good information on part of the reach. And again, I want to thank Jason because it's really been a lot of the Fish and Wildlife Service. And it kind of started with trying to understand what was happening in the refuge, in the Toppenish National Refuge, because there was pretty high mortality in some of those ponds. And then as they were looking into that, and I don't know, Jason, do you have 18 arrays or something? You have a lot. We sort of started building them upstream, and we came to understand that the area where the Lawrence ditch is, for example, had extremely high mortality. You know, once the situation in the refuge was being addressed, we realized that there were other zones, pretty big areas, where there seemed to be a lot of mortality. So we have a rough idea. We don't have the trap where the fish are tagged, where the smolts are tagged. It's about in the middle of the assessment reach. So upstream of there, it's harder to understand what's going on because you trap them and tag them. And then downstream of there, you can really do pretty accurate numbers of, you know, based on the number you tagged, how many you pick up. Upstream of there, we don't have that capability yet. We can only look at the sort of physical things that we're pretty sure might affect fish migration. Is that the kind of information you wanted?
Yeah, and it kind of goes a little bit back to what Pat was talking about of, you know, you have a lot of miles to cover. You know, do you focus somewhere at the start, or do you start at the bottom and go up? You know, and does more contribution to mortality sort of inform where you might start or put some focus, or maybe in the end it focuses on where you make your best efforts once you do the assessment. But that's kind of where I was going with that.
Oh yeah, I think that's a great idea, and yeah, for sure, the area between the area of the Lawrence ditch, where we already know there's high mortality, is going to be a focus area, and for sure we want to check that out and be sure we give that our full attention. Versus, you know, walking up, you know, parts of the fan where it's dry in the summer and there's no smolts and there's not a passage issue because there's not even water. So, you know, this is, again, I feel like I worked out the time okay, but I think you're right about focusing on the areas that seem more suspicious first.
Yeah, suspicious, that's a good term for yeah, focus on the suspicious areas.
Yeah, the Lawrence ditch is highly suspicious. So
Doug had a comment or a question about smolt loss in Snake Creek, and then Alex looks like responded to it. So Doug, did that answer your question, or do you have more about that for Tom?
No, I think we're good. From my understanding is the previous, what we heard was somewhat looking at a fairly small area, and they've chosen to go the grand plan first, which I have no problem with. That sounds like a good place to start, in because they'll find areas in addition to Snake Creek that need some thought and some better management. So as I stated last time, it from looking at this and looking at the Snake Creek and looking at the irrigation diversion there for the Sunnyside Valley, I think we need to invest in getting our smolts back into the mainstream more than we have in the past. Seems to be a serious problem.
It must be spring. I hear those birds chirping in the background.
yeah, someone has some nice birds.
Other questions for Tom? Yeah, see about the screen shop.
Yeah, Alex is writing what he texted back. And again, Jason has a hand in that. And yeah, that we intend to and want to work with the screen shop we have before within the reservation to get screens in. So be something that we look forward to.
And my comment on the screenshot was specifically, Josh Regala has done more than anyone else to try and figure out how to bend the WDFW protocols to match all the strange things we do to creeks in central Washington for the sake of irrigation. So he's long been the one leading the challenge to broaden WDFW Olympia's sense of what barriers look like and how to assess them.
All right. Well, if you don't have any more questions, I appreciate your comments and questions, and I will definitely, my takeaways are thinking about, as still kind of far off, and of course, should we get the award, I will definitely put time into and work with DFW to see how we might tweak the database so it's ready for this sort of, less common type of information about, unorthodox or whatever unconventional barriers, and then I'll take a hard look at the budget too. Sooner, just to be sure that I think we're covered.
Great. Thank you very much, Tom. Appreciate you coming back.
Yeah, thanks everybody. Have a good afternoon.